Good afternoon, Professor. So this is my personal timetable of this week. So last week I was preparing my paper writing and conceptual figure plans, and we sent the samples for FESAM, AFM and FTII also, and preparing the comparison table and figure preparation for my paper. And I had a meeting with Dr. Daniel for equivalent circuit of my D5 chip, and I also had a meeting with Dr. Sachin to remove plagiarism part from RF biosensor paper, which we received the email by our professor. So for the TA work we had a class RFIC class EDS, prepared the EDS class PPT and preparation and submission to KLS system and supporting new students. I went to international office for the LEMI. They said me that he needs to submit IELTS and TOEFL exam scorecard to get the scholarship. So for this week, as professor asked me to continue my paper writing as soon as possible, so I'm working on my paper writing and conceptual figure also. And this week I will be doing the results analysis of SAM, AFM and FTIR for my paper, and I finished the comparison table of different techniques for the detection of virus. And for the RF biosensor paper, I will have meeting with again to remove the plagiarism parts. And this week we have a class on today, and continue support for the new students. So this is paper summary for our paper corona detection, and all the advantages already included these advantages in my abstract parts. This is a paper for AD detections. This is another PSC sensing with Dr. Sachin using the graphene nanocomposites now. This is my future planning paper for toe protein detection using IDC chip with the following advantages of future perspective. So this is our SARS-CoV detection plan using a graphene biocomposites. So for my paper, this is a table of contents, and all the content for paper, as most of the things I have finished. Just need to write some surface characterization part. This also needed to finish this part, and I write the chemical and equipment optimization and analytical statistics activity and sensitivity as well. As I just need to time to analyze the results part, so I will finish this maybe this week. This is a title and all the parts for my paper. There are some future candidate I already asked to professor and presented to professor with ultra fast diagnostic and detection part. As professor asked me to highlight our main concept, I highlighted here capacitive detections, selectivity, sensitivity, real-time capacitive detection for the point of care 3 seconds part. SARS-CoV, this is our sensor configuration, IDC plus TIPT, GRO, IDC NHS, antibody and antigen, and 3 seconds of detection. So this is my keywords. I included SARS-CoV, integrated capacitor, antibody, plasma, real-time detection and biosensor. So this is my introduction part. Most of the part are finished with all the references. So this is continuing my introduction and all the references. Now we need to modify the references as per the biosensor bioelectronics genre. Again the continuing my introduction part. So prepared on whole table with different concepts. This is virus detection, method of detection, materials, limit of detection, and references. For my paper I finished this table. So here influenza virus and Ebola virus and dengue virus and Zika virus, SARS-CoV-2 virus with different method of detection like electrochemical, optochemical, and electrochemical, and using the graphene oxide. Some people use reduced graphene, some people use graphene oxide, some people use silver nanoparticle with graphene oxide. So I already summarize all the materials and methods with the limit of detection. So this is a complete table. I finished the table with the abstract parts. So this is our study here. This part is our study SARS-CoV-2 detection. Our method is capacitance, and this is all the layouts of our chip: IDC, BTTI, graphene oxide, EDC, NHS, and antibody, which is a really nice combination for the sensing purpose. And our limit of detection 0.1 picogram per ml. This study. Sir, in this paper I introduce a new concept, developed protocol to functionalize PTTI chip and with all the chemical process. I have written here how we functionalize our chip for the piranha cleaning and like graphene oxide emulsion, then antibody emulsion and EDC NHS emulsion with all the authenticated references. So previously I had a meeting with senior Dr. Daniel, and I prepared this figure which is a single layer equivalent circuit, but Dr. Daniel said me, because we have here two IDC structures, so we need a double layer equivalent circuit. So I prepared double layer equivalent circuit, but I asked professor said again change to this one. So I asked Dr. Daniel to change this figure with the new equivalent circuits. So I prepared a new figure, developed protocol to functionalize TRPT interdigital capacitor, which is our wafer graphene oxide sheet. Here we can see emulsion graphene oxide sheet, and then reaction of EDC NHS here, and this one is a silicon dioxide and the graphene oxide part, and this red part I can say like a EDC NHS structure with a free OH bond. And then this is a antibody, which is a spiked antibody, which is having a bond here NS2, which bind with this bonding in amide bonding means, and the final schematic, which is like chip with graphene oxide, EDC NHS, antibody, and this is our antigen, which is basically a spiked antigen. So this is all the concept for my paper. So this is a one picture I prepared with the help of Chaya, and preparing some new schematic for my paper. I need some time to prepare some schematics, so I will prepare after finishing my writing part. So this is one which we have. so need some changes here again. One picture I prepared with this one and this one for my schematic part, sir. After my writing content, I will combine all the picture and make a new schematic. This is our SAM FNM which we sent already to NanoPaps. We received some results and I will be analyzing the results part in this week. So this is our equivalent circuit. So I discussed this equivalent circuit with Dr. Daniel. So how they make that circuits for the IDE chip. We have a new concept in our this corona detection paper, water and GRO and EDCNHS contact angle. By the help of contact angle, we can analyze that the surface is wide hydrophobic or hydrophilic. Hydrophobic means water repelling, hydrophilic means water attracting. If this angle is high, so we can say the surface is hydrophilic. If this angle is going low, it means surface is hydrophilic and our distribution of material is chip is little equal distribution, right? So this is our stepwise process. This is the supporting materials for my paper. I'll be using this source of supporting material for the TA work. uh, we're preparing the video preparation for the next class, PPT presentation and lecture and final term exam. So I will discuss some questions with Jaya and prepare the question for the final term exam. And assignment checking, students send me the assignment, so I'll be checking the assignment with Chaya. And student also asked some queries regarding the final exams and PPT, so I will be resolving the queries as well. This is my personal achievement plan, so I'll be writing the papers, and one paper is published with Dr. Sachin, and this is my conference or seminar abstract part, which is already have been accepted or published. So that's all, professor. Thank you, sir.